Dear student, welcome to the next part of application of partial differentiation of engineering mathematics 3. In this part, we will discuss property number 3. Okay, see the statement. Let's see the statements. If function UVW of three independent variable x, y, z are not independent variable, then del of u comma v comma w upon del of x comma y comma z is equals to 0. Okay, what is the meaning of this? Okay, we have to given that UVW are three function, and you can find this functions by using determinant. Then we will get 0. We can say that there is a functional relationship between in these three variable, otherwise there is no any relation. Okay, now see the note very carefully. If UVW are function dependent, if determinant is equals to 0, it means that same we have to given three functions and then find the jacobian. We will get 0. Then we can see that there is a functional relationship in between these three variable. Okay, now let's see the one numerical example. Verify whether the following functions are functionally dependent, and if so, find the relation between them. It means that you have to firstly check there is this function is a functionally dependent or not. Okay, we have to given u is equals to x plus y upon x minus y, and phi is equals to tan inverse x plus tan inverse y. Now we have to given that u is equals to x plus y upon x minus 1 minus x into y, and phi is equals to tan inverse x plus tan inverse y. Okay, now how to find step by step? First you find jacobian. You have to given two function u and v and two variable x and y. So jacobian of del of u comma v upon del of x comma y, which is equals to, arrange the jacobian in the determinant form. First row is del u by del x and del u by del y. Similarly, del v by del x and del v by del y. It means that we have to find partial differentiation of u with respect to x, similarly with respect to y, and we have to find partial differentiation of v with respect to x and similarly with respect to y. Okay, del u by del x means u is equals to x plus y upon 1 minus x. We have to find this term by partially, then we use the u by phi rule, because of u is in terms of numerator and denominator. So, okay, we know u by phi rule. What is u by rule? Firstly, phi as it is, derivative of u with respect to x minus, now phi as it is, u as it is, and derivative of phi with respect to x divided by phi square. Okay, here u is given x plus y and phi is given 1 minus x into y. So 1 minus x into y is as it is, and derivative of u with respect to x, u is x plus y, so derivative is 1 minus, now phi is as it, u is as it is, u is x plus y as it is, and derivative of phi with respect to x, phi is 1 minus x into y. What is derivative of this term? Is derivative is minus y. Now upon divided by phi square. Phi square means 1 minus x into y whole bracket square. Now simplify this term. 1 into this term is 1 minus x into y as it is. Similarly, minus into this term is minus into minus plus xy, and minus plus y into y is y square whole divided by 1 minus x into y whole square, which is equal to this minus xy plus xy get cancelled, remaining is only 1 plus y square upon 1 minus x into y square. It means that we get del u by del x is equals to 1 minus y square upon 1 minus x into y whole square. So I am writing here 1 plus y square upon 1 minus x into y whole square. Similarly, we can find del u by del y with, it means that partial differentiation of u with respect to y. So we will get 1 plus x square upon 1 minus x into y whole bracket square. We can use hold this procedure by calculating the del u by del y. Okay, now find this term. What is meaning of this? Partial differentiation of phi with respect to x. What is phi? Phi is a tan inverse x plus tan inverse y, but we have to find with respect to x only. That's why derivative of tan inverse x is 1 upon 1 plus x square. Similarly, derivative of partial differentiation of phi with respect to y is we will get 1 upon 1 plus y square. Determinant is complete. Now solve this determinant by cross multiplication and subtraction. 1 plus y square upon 1 minus x into y whole square multiplied by this term 1 upon 1 plus y square minus 1 upon 1 plus x square upon 1 minus x into y whole square multiplied by this term 1 upon 1 plus x square. Look at here, 1 plus y square upon 1 plus y square get cancel. 1 upon 1 minus y square, sorry, 1 minus x into whole y, x into y whole bracket square minus this term is again cancel. Remaining is only 1 upon 1 minus x into whole bracket square. Look at this term, 1 minus x 1 minus x into y whole square, 1 minus x into y whole square is same. So I'm writing here 1 minus x into y this square is equals to, sorry, 1 minus 1 is 0. That's why 0 upon anything is again 0. It means that therefore you can say that j is equals to 0. It means that determinant is equals to 0. It means that there is a functional relationship between u and phi. Okay, so there is functional relation between u and phi. Okay, then how to find relation in between u and v? So we have to give one phi. What is phi? Phi is tan inverse x plus tan inverse y is equals to, I'm taking u. What is u? U is a tan inverse, sorry, u is a tan inverse of x plus y upon 1 minus x into y. Now next term is, I'm writing here, tan inverse x plus tan inverse y is equals to tan inverse of x plus y upon 1 minus x into y. Okay, again tan inverse x plus tan inverse y is equals to tan inverse of, what is meaning of this term? This is a u and this whole term is phi. We can say that phi is equals to tan inverse of u. This is a relationship between u and phi. Or we can simply say that u is equals to phi upon tan inverse of x. It means that u is equals to tan of phi. You can simply say this, or we can say that this term is in terms of or. Okay, thank you student.